Yeah, hello everyone, and welcome to this first STACKIT meetup for this year. So great to see so many of you attend for this meetup, and also to you on the live stream. Hello. Yeah, we will show you here or our meetup is called STACKIT Cloud and Kubernetes, and we want to go with you on a journey from the Schwarz Group to the cloud to Kubernetes. And we will also dive deeper into some topics, so it gets a bit more technical the deeper we go. We have 5 presenters in total, so thanks also to the colleagues from the SKI team who will show something to you. If you have any questions, feel free to raise them afterwards. Yeah, we have prepared around 30 to 35 minutes, and then also enough time for questions. And for you on the live stream, also feel free to post your questions to the chat, and we will then go through them in the end. Okay? Perfect. So let's start. I'll just give you a short wrap-up. What is the Schwarz Group, what we are doing, and why we are building our own cloud. So you can see here the Schwarz Group. Probably most of you or all of you know Lidl and Kaufland, our biggest business. We are in total divided into 4 departments. Retail, here you can see it on the top left side. Production also, recyclables, we are really getting into, or we are really deep into, and then also on the bottom, the Schwarz IT. Yeah, and this is also where me and all of the other colleagues are belonging to, and we are building IT solutions for the Schwarz Group. And now we are building our own cloud. Yeah, this is called STACKIT. So we have 4,000 people in total working in our Schwarz IT department, and we need reliable infrastructure. Yeah, we need cloud products. And for this, we decided to build our own cloud. We were we had the decision to make, are we going to a large hyperscaler, to a different cloud provider? How is our digital journey looking like? And we decided on our own, like I said, 4,000 people working in IT. We have different services, products, like the Lidl Plus app, like ERP systems, data warehouse systems, and so on, supply chain systems that we need to have reliable online. So we decided to build our own cloud. And this is where we are all belonging to. You can see it here on the timetable in the bottom. So we established STACKIT around 2018, 2019. Then we did some internal testing, onboarded some friendly customers, and then we had our go live last year in March. You will also see how our product, how our whole STACKIT product, our whole platform looks like, and also how the Kubernetes engine looks like later on. Okay, and now we go into the more technical side. Yeah, we now go to the journey, how we did deployment in the past and how we are doing it nowadays. Yeah? And this is also the way or the reasoning why we are using Kubernetes these days. So you can see it here on your left side, exactly, the traditional deployment, how we used to deploy things. Yeah? And you can see it here. This is also what you know from your home personal computer, where you have hardware. It's comparable to servers then. Your host operating system, maybe you're using Windows, Linux, Mac OS, whatever. This is also applicable to the cloud or to servers, and then your applications. The problem is here that you have missing resource boundaries. So one application could take all of the resources that you are using, and it's hard to automate. So you need your application scales, and then you need new hardware, a new operating system, and it's not automated in a way that you can configure this easily. I think the technology is quite old already. We discussed it previously, around 50 years already. We came to the virtualized environment. Yeah? This whole concept that you are using your hardware with VMs in a shared environment, basically. Okay? So you deploy VMs, and the most important thing is here the hypervisor. This is the software that is used to spin up these virtual machines. With virtual machines, you can then allocate resources, basically, and say, okay, we have this pool of resources, and each VM gets his own share that you can then use. Also here, you can see the operating systems on top of the VM. Show it to you here, that you can then deploy different systems on top of this hardware. Okay, and now we have this virtualized environment. Our resource utilization is already getting better. We have improvements here. The scalability, automation gets better. Why do we need containers now? And now we are getting to this cloud native environment, to this where we are heading nowadays. And what is the problem here is that for every container, or for every VM you want to scale now, you need a new application. You also need to install your operating system. And this is the big change, what containers brings us. You don't need to install your own operating system for a new application. And this is it. Like this is where containers bring a lot of help. We have then smaller images. You can see here the container runtime. For example, I've heard or I've spoken to you. Some of you have used Docker. Containerd is an example, and these all take some responsibility from this. Okay, why are containers now so great? The biggest reason I told you that you don't need to install the guest operating system, so they are really lightweight. You can scale them up, you can deploy them way more easily. You have smaller images, so especially in this cloud environment where you don't have resources available or where they are not there all the time. So a VM could change, a hypervisor could get an update or something, and you need to spin up new instances. There are containers especially important. So it's just way easier to have them there. Additionally, they are portable, so you can develop and deploy on your own machine. You can bring them to the cloud as long as the container runtime is the same. It's running on your machine or anywhere else. Additionally, containers are modular, so maybe or hopefully or probably some of you have heard the term microservice-based applications, where you then can scale up different parts of your application, and this is way better to do it with containers. So you could, for example, scale your backend if more and more requests are coming in, and so on. Okay? And then one last thing is the major ecosystem that has been built around containers. So you could maybe go to Docker Hub, see some pre-built images from companies, from individual contributors, and you can make use of this ecosystem that is building around containers. Okay, perfect. So in general, containers are the standard way to develop and deploy applications nowadays. We are using containers every day with the managed Kubernetes offering that we are providing, and they are just the standard. So in general, containers are great. What is now the problem? The problem is now that you have a large application that you need to scale, and that you have more and more containers. Let's say, for example, Netflix. Okay, Netflix is a huge application providing streaming services to millions of people around the world. And if you're now using this container system or containers and you don't have a management for them, they are lightweight, we told you. They are just, you have more of them. And then it's hard to orchestrate and maintain them, to manage them. And Kubernetes is exactly this. It's the management system for your containers. Okay? So what does Kubernetes now bring to you? Kubernetes solves a lot of typical challenges that are coming up with containers. You have, for example, scheduling, like I said, or you have a large environment of hardware. So where should my container run? Where's some resources left over that I can use? Also inter-container communication. There Kubernetes helps. Resiliency. Let's say my application fails somewhere, a container breaks down, Kubernetes takes care of this, sees this, and deploys a new one. You have also adaptive scaling included. So also more requests are coming in, Kubernetes recognizes this and deploys a new container to it. Resource optimization, you can tightly configure which containers should use which part of your resources. You have isolation concepts in form of namespaces, maybe some of you have heard this, and authorization concepts with role-based access control. Logging and monitoring is standardized and is way easier with Kubernetes, and also storage. Like, let's say you need persistence for your container, for your application. Kubernetes helps a lot with this too. These are just some parts, there are more, but I think these are the most important things. So Kubernetes itself shines as a platform for platforms. All right, put the mouse a bit away. But it's highly complex. Or the platforms for platforms, we are also using this a lot. Kubernetes is also, or has the possibility that you can extend it. The Kubernetes API server is highly extensible, and we are using this daily to provide our service to our users. Okay, but the problem is it is complex. Kubernetes brings a lot of benefits, but the setting up and the operations of all of this, that you have some system in place that monitors containers, that is there for scaling, that is there for fault tolerance, and so on, it's hard to set it up. It's getting better nowadays. We have some tools in place, but it's still super hard to also do day two operations, like updates of your Kubernetes version, and so on. So this is something that we take care of as the SKE, so STACKIT Kubernetes Engine team. So what you get when you come to us, you get a managed Kubernetes offering. Then you can do with this whatever you want, whichever containerized application you want to run with. What we are taking care of is the control plane, all of this system around this. So it's cost efficient. For us, you pay around 70 euros for the control plane management per month. So yeah, like I said, the setting up and so on is important, is hard. So it also reduces overhead when you go to a managed solution. Additionally, it automates the boring parts, like updates, for example, certificate management. This is all taken care by a managed Kubernetes provider. And it's the de facto standard today if you want to deploy, develop production-ready applications. Okay, and now we are not the lonely or the lone cloud provider in the world. There are some other alternatives. Now I want to mention a few points why we are convinced that SKE is the right choice for you. And first of all, or you could see it in the beginning, we are a German company, there for German companies. We have these 4,000 people in IT, these different applications that we know where the pain points are, where the problems are, and we are focused especially then with these use cases to also provide these services to also the external market. We support our users on their journey to the cloud. We have a large professional service team that you can talk to, get into contact, that they also know your problems, and that you can have your way to the cloud way easier. Next up, we focus on privacy, and this is the biggest reason why we started our own cloud. We want to have data centers in Germany. We don't want to be dependent on the American hyperscalers, on Chinese competitors or whatever. We think, or we are convinced that there's a large gap in a European alternative that is GDPR compliant, that is ISO certificate, and that really focuses on privacy things. And lastly, we value simplicity. We really have the developer journey in our mind. We want to build the most, or this really simplified platform where the developers, where product teams can use cloud products for their applications. And Simon will now show it to you how it looks like.
Thanks, Julius. I hope you can hear me all right. Sounds good. All right, perfect. I'm gonna step out of the presentation for now. And great. Gonna log back in. What is happening? I have to. Oh. All right, perfect. Sorry for that. Yeah, so we heard about basic concepts of Kubernetes and containers. Now let's get a little bit more hands-on. If you're here for the really juicy technical parts and the command line, don't worry, that's gonna come up in just a minute. For now, just like, because we don't know where exactly you are in your cloud journey yourself, we just wanna show you how to actually interact with us as STACKIT and the SKE, so Kubernetes Engine. There's a few ways. I'm gonna show you two today. One is our portal, which you can see behind me. The other is our API, which I'll show you in a minute. And just by show of hands, who has used hyperscalers before? AWS, Azure, Google Cloud. Great, some hands, thank you. So if you've seen their dashboards and their portals, you probably know they're quite overloaded, they're quite complicated, you don't find stuff right away. So what we focus on when we build our portal is really simplicity. You have your dashboard here with all the important information about your project. You can see all the different services that we as STACKIT offer, our databases, computing, and the runtimes down here, where we also have the Kubernetes engine. And you can see your cost overview and what quotas you have in your specific project. And as we said, we value simplicity. I hope you agree that this is quite simple and beautiful to look at. So let's jump right in. and create a Kubernetes cluster, as we say. We create a Kubernetes cluster, which consists of our control plane that we take care of, and then you can go ahead and create it. Let's say it's called the Sunset for now, because we're gonna be there later at the Sunset social. So you get some basic options which you can use to configure your cluster in the beginning. I'm gonna show you some advanced options later. For now, let's stick with the most recent supported Kubernetes version. We offer a few of them, but let's stick with the newest one. And of course, we continuously provide new Kubernetes versions for you. And also the update process is taken care of. As Julius already said, the boring parts that you don't usually want to do in your day-to-day operations, like updating your OS versions or your Kubernetes versions, that's taken care of by us. And you can focus on developing your applications that you actually want to run on this cluster. Maybe a fun thing to show, we talked about simplicity again. And we really focus on integration with other STACKIT products. So there's this product called Argus, which is our monitoring service we host at STACKIT. And we really wanted to make sure that it's easy to use that. So by simply clicking one button and selecting our Sunset Argus instance here, I could go ahead and simply integrate monitoring. That means, I don't know if you heard of Prometheus, Grafana, Loki. That's the basic monitoring setup that most people use today. So that's out of the box integrated. If you enable it here, I'm not going to do that for now because of time. So let's create our node pool. The important distinction to make here is that Kubernetes has the control plane, which is managed by us, where all the data resides, like what is going on in your cluster, which is managing the cluster. But then you need some workers to actually do the work for you. They host your applications. They host your data batch processes that you might want to do overnight and crunch some numbers if you're into data engineering or stuff like that. So let's go ahead, see what we have here. As you can see, we can select a number of nodes. Nodes are just the workers that actually are just VMs that we get directly from a neighboring team called EAS. They host our VMs, and we just get them to you in a Kubernetes cluster, bootstrapped and everything. So that's great. And I'm going to just select a range here. So the minimum number of nodes is 2, which is enough for just a small demo. And it could scale up all the way to 4. So if your dynamic workloads have some different resource requirements, Kubernetes is intelligent enough to actually get that up and down for you, and therefore fulfills the requirement of efficiency because you only pay what you actually want to use right now, instead of like with the first traditional approach that Julius showed on his first slide, where you have a big hardware VM or a hardware server standing around, which is going to cost you no matter if you're running something on it or not. All right. We offer one image, which is called Flatcar. It's perfect for containers. It's very lightweight and pretty secure. And also, as you can see here, we continuously provide new versions for that. That's quite convenient. And then we have all the flavors that we want. And I'm going to go for a general instance right here with 4 CPUs and 16 gigabytes of RAM. That's a little bit weird with the display. I'm sorry for that. But no matter, we're going to go ahead and create that node pool. So as you can see, we have now the control plane with the fixed price that you said earlier. And the price for the VMs that actually do your work are depending on exactly the kind of workload that you want to host on that platform. I'm going to order that now. And that is creating, fully automated. And while that is creating, I want to see some hands again. Who here has used the REST API before? Yeah, great. Like to see that. Okay, then I could have skipped the portal part then. Great. So, of course, you don't want to interact by clicking around every time and selecting the Kubernetes version and going all that down every time. You want to automate that stuff, right? So you can do that. We go with the API first approach. Everything that we offer as features is definitely available in the API, which we provide as an open API spec. So you can go ahead and configure every client that you might think of. Let's say your favorite programming language, use some curl or a Postman, whatever you need to get started. You can go ahead and use that. And then just create or update a cluster like we just did, but with a programmatic approach. So you can go ahead, select one of our extensions. I already talked about Argus, our monitoring. We also have access control if you want to secure your cluster further by limiting access to the control plane. And then we offer some other features like hibernation, when you put your worker nodes to sleep overnight to, again, save some money. which is a quite convenient feature in my opinion. And you can also select maintenance windows. This is where we do the boring part, as we said before, where we update your nodes and your Kubernetes versions. You just have to select the time window where we do that for you. So with that, you can go ahead and get your cluster automated. You can use approaches like infrastructure as code. If you've heard of that, like declarative deployments and stuff. So you can just set up your infrastructure, automate it, and continuously apply it instead of clicking around, which is great. So I showed you 2 versions of how to get your cluster. Now the big question is what to do with it. And with that, over to you, Raphael.
Thank you, Simon. So my name is Raphael Grömmer. I'm a cloud engineer at the SKE team. And I quickly jump back to the slides. So yeah, I want to tell you something about, wait, that was too much. So now, here we go. So I want to tell you something about how you can access your cluster, so how you get applications on top of Kubernetes. So thanks to Simon, we know how to order our cluster. We can then download the kubeconfig, which has the authentication to access your cluster. And now we want to deploy the application. In Kubernetes, we have different kinds of resources. So different resources have different use cases. So basically, I prepared a small example application. We can here see it consists of 4 different resources. We have a namespace here, which is a kind of logical isolation for the application. And inside this namespace, we want to deploy our application. It's consisting of a deployment. A deployment is that part where I can specify my container, so which container should be executed. In this case, it's an HTTP web server. I have a config map here, which I can configure my web server or any kind of deployment I want to configure. So I have some files in it or configuration stuff there. And we have at least the service part, so the network part, which we can access our application. This kind of resources are all declarative written in YAML. So you could save them up and push them to a Git repository or something else to work together on an application. And now we want to deploy this application to our cluster. In the ecosystem, we have multiple tools to do that. So the first tool, the official way, would be the kubectl. So it's the official command line tool for Kubernetes. So we can deploy or we can apply single manifests to a Kubernetes cluster. For example, with the command kubectl -f deployment.yaml. Another great tool which I want to talk about is Kustomize. So Kustomize is a tool to deploy an application. So basically it bundles an application in a so-called customization YAML. So I could write one file and therefore I can specify all this kind of resources and I can deploy an entire packed application with one command. Another great thing with Kustomize is the overlays. So I could define a base application. And for example, in a productive environment, I have different stages. I have an application in test, QA, and prod environment. And for example, I want to use different versions in the different stages. I could then create a base application, and with overlays, I can say, okay, I want to use another version in my QA environment, for example. The last tool, which is also really great, is called Helm. So here we also bundle our application in so-called Helm charts. The thing here is that we could use a templating language inside our manifests. So for example, with a deployment.yaml, we could there specify some variables and say, okay, we want to use a version on a container, and we have then a file called values.yaml where we can define these variables. So of course we, or for example, we could make multiple values YAMLs with different versions in it. So now let's go to the demo part. I already deployed this application. And I just want to show you how to access it. I will therefore make a port forward. So basically what I'm doing here is I port forward my application in the namespace SKE demo, and I want to port forward my service called SKE demo with the local machine port 8080 to the container port 80. If I execute this command, so I'm now have an open connection to my Kubernetes cluster, so I port forwarded it, and I can go to the browser and open the localhost. And I see the small demo application here. And now I think Kai will tell you something about how to deploy these kinds of manifests.
Thanks. So I'm going to show you what Raphael actually deployed. So he talked about a lot of different approaches how we can deploy our applications, and in our case, we've deployed it with a customization YAML. So I'm quickly going to show it to you. So it's not that big. We have the namespace at the top, which basically specifies in which namespace all the applications will land. And then we specify 3 resource files which are already defined, and they will get deployed. The last thing is a so-called config map generator, which is really great to automatically create config maps out of files. So in our case, it contains it has the HTML file which you have seen on the website. So we could deploy it with kubectl. Often it's alias to k, just k. So I can say k apply -k for customize and point to the current directory. And now we should see that nothing got changed because, yeah, obviously it's already deployed. What I can also do with kubectl, I can get pods out of the SKE demo namespace. Now we can see, okay, currently we have 1 pod running. For example, if I want to scale my application to more multiple replicas, I can use the kubectl scale command and scale the deployment to, let's say, 10 replicas. And now if I execute the get pods again, I should see the containers coming up. And also, Kubernetes is doing load balancing via the service. So if a lot of requests are coming in, they will all get distributed across the pods. What I can also do is I can take a look at the manifest, that is actually deployed. So I can obviously just get the deployment, but with the output flag, I can specify the format which I want to get. So that's the YAML output. In our case, it's quite large. Don't be scared of it. I will just get over a few ones. So obviously, we have the metadata object that contains obviously metadata like the name and the namespace. But more interesting is the spec object, which contains all the specification of the deployment resource, such as what image is being used and what ports are being exposed and the volumes which are being used. In our case, it's, as I said, the config map. Yeah, what I can also do is I can create applications or deployments directly via kubectl. So I can use the create command, say I want a deployment, I want the image alpine, for example, and give it a test name. So now a deployment is instantly being created. That will now fail because, yeah, there's no command that's running in that image. I can also get all the namespaces. And to wrap up my part, we have the nothing to see here namespace, which probably Felix can tell you more about.
Yeah, thank you, Kai.
So now you saw how to deploy applications on Kubernetes clusters, and our product owner Julius just came to me and said that one of our clusters got some failing applications, and I thought, what a great time to debug this application with you together. So we also run on Kubernetes. So we often use a tool called K9S, which is like a terminal UI for interacting with Kubernetes clusters. So yeah, it's pretty easy. You can start it with K9S, and then you see like a more beautiful UI popping up in your terminal, which basically, for example, you can list all pods in. So, for example, now you see that there's a test pod failing, and yeah, but Julius said that there might be another application failing. So what we do to figure out is, first of all, we're going to filter for all pods that are not running. And there we see in the nothing to see namespace here, there's like not a Bitcoin miner. And let's see why this is crash looping. We can have a look at the logs. And there it says the error, the coin type configuration is missing. Okay, this is kind of weird, so there might be some configuration missing. We go to the namespace and let's use the X-ray plugin to see what this container actually consists of. So here we see we have this this container, which is red because it's in an error state, and we see that there's like 2 config maps. One is a command, one is a configuration. We see there's some like airbag security groups, and then here's the actual pod that is running. And I think it says something with configuration, so maybe we check out what this this config part here is about. Okay, it's a config map. Let's have a look at it. Oh, in the data field here, it specifies a wallet ID, which says product owner's wallet ID. And if I remember back to the error, it was like there was a coin type missing. So what we do is we edit this config map. We go and type a new key, which is coin type, and let's say like Ethereum. And then we just restart our pod. And we see, oh, it's an error state again. Damn, I thought I fixed it. But at this time we got another error. So it says like, secrets is forbidden. The user service account cannot list resource secrets in API group. Okay, we saw earlier that there's like an RBAC group role, something like this. So let's see what roles we got here in our cluster. Okay, there's this some app role. And if we go into it, then automatically K9S opens the Raquez plugin. And this lists all resources that this service account is attached to. So here we see that the service account has some rights for the secrets, and this is what we have the error for. And then you can see that the get and watch requests, they are allowed, and all other requests are not allowed. So yeah, I think it said like secrets, he wanted to list all secrets, which is like kind of suspicious, but okay, we're just going to say that it's allowed to do that. So we added the role again, say, okay, you can also list secrets, save it, restart our pod again. It's creating, and this time it's running. Okay, might be good. Okay, it listed all secrets, so there's just one secret, and then it says definitely not mining Ethereum coins for wallet ID, product owner's wallet ID. So I think, Julius, we fixed your cluster again, but I'm not quite happy with it because I'm a little bit thirsty right now. So maybe so I got enough money for tonight. Let's just spice these things up a little bit. And also, because I would like to pay my rent, we can go to the deployment, maybe scale it to 10. And now, I think now it's fixed, if it's okay for you. Yeah, so, yeah, what have we learned? So with K9S, you can actually edit resources, you can list resources, filter resources, you can even see logs and stuff like this. So this is like a great tool for us to debug our clusters and our applications. And yeah, it helps a lot if you can do stuff with it on the command line. And also now it helps me paying my rent for the next month. And yeah, Julius, get back to you and a little wrap up maybe.
All right. Thanks, Felix, for the demo, but we will talk about this later on. Yeah. Okay. So let's wrap it up. We have now seen, you have seen a broad overview about STACKIT, about cloud products. You've seen our product, what we have, our portal, the APIs. We have deployed our Kubernetes application. We have changed them, and we have also debugged an application. So we got now a whole broad overview about this topic. And if you have any questions, feel free to reach out to us. We have a Q&A afterwards. And also, what I forgot to mention in the beginning, obviously you're all invited to the Sunset Social later on, where we have some snacks, some free drinks, and please just reach out to us there, and we're happy to get into contact. Some STACKIT principles that are written down here. These are the first things that come into our mind when we design and develop products, are stability, security, and simplicity. So we have not only the Kubernetes service, which you could see in the portfolio, also other cloud services, and these are always the principles that we are working for. And then also our team values here below, which we are really striving for. Commitment, cooperation, curiosity, excellence, honesty, and also open source. Kubernetes is an open source tool. We are using Gardener, an open source tool for managing all of these clusters, where we contribute back. You saw a lot of tools that are open source, and this is just something that we are also striving for and want to be in this space and continue doing this forward. All right, that's it from our presentation. Thank you all for attending here. And in case you have questions, feel free. Are there some questions from you or otherwise from the YouTube audience? Yeah, okay.
So I don't want to spend like 70 euros to start with Kubernetes. Is there any other possibility for me as a single person developer to just start right off with Kubernetes?
So I guess you have your laptop, your own personal computer at home. So there are some tools, K3S or also Kind, what we recommend for local development on your machine. If you just want to get started with Kubernetes, if you have your own machine, not a whole data center to use, and don't want to spend so much money, this is the recommended choice from my side, from our side.
Thank you.
Yeah. Any other questions regarding all of the topics that you heard?
So apart from Kubernetes, what other services does STACKIT offer?
Okay, good question. We can go into the portal real quick. Find it here. Dictionary. Vivaldi. Yeah, okay, perfect. Okay, I'll give you a quick tour of our products. Yeah, so what Simon showed you already is the dashboard. Then we have here our services section, where we combine just services that you need for your application. These are the cloud products that we offer. A Maria database, MariaDB, Elasticsearch, LogMe services, RabbitMQ for messaging, MongoDB, Postgre, STACKIT Argus, this is our monitoring and logging and tracing service, which you could see in the beginning during Simon's presentation, where we have the integration built in directly. And this is also something we strive for the other cloud products that you can see here, so that you have this whole experience within your Kubernetes cluster. We have more versions of these. Redis is also here in here, and then some other versions. Okay. Then we have also some two dedicated product teams with talented engineers for our database services, MongoDB Flex and Postgre Flex. They are new in our portfolio. I think they went live 2 months ago, roundabout. Then we have the whole infrastructure layer. This is something which we are also building up on. So we have the data centers in the lowest layer, then our infrastructure team, the IaaS colleagues, where we are getting our machines from, our storage, our routers, and so on, which we are using then on top with the Kubernetes layer. And yeah, then we have the cloud products that you see, which are running on top of Kubernetes itself. So it's layer after layer. But the infrastructure layer is mandatory for our Kubernetes service. So you could also create VMs, disk volumes. Also, we have an object storage service. Then both of our runtimes, Cloud Foundry and Kubernetes. We have a secret manager, new in, networking products, and then you can see here in the end information, audit log settings. So these are not our products, but we are continuously improving our portfolio. We are working on new products all of the time, and this will be extended in the upcoming weeks and months. Okay. Any other questions what you're interested in?
You mentioned that STACKIT also offers Cloud Foundry as a runtime, but also Kubernetes. In which situation should I use Cloud Foundry, and in which situations is Kubernetes the better choice?
Okay. Great question. You've mentioned both of our runtimes. I will also show you real quick how it looks like in our Cloud Foundry organization. So the biggest difference, what you could take from here, they are both container runtimes. So both of them are built around containers. You want to deploy them. You just want to have your containerized applications with both of these runtimes. The biggest differentiator, I would say, between both of them is that Kubernetes is more complex, but you can also do more things, or it's more, you have a higher configuration freedom, I would say. With Cloud Foundry, you can get started easily. It's also scales quite well, but it's you don't have the whole configuration freedom that you would have within Kubernetes, where you can set up different services, extend it with custom resources, and so on. Additionally, Cloud Foundry also brings you a lot of things which Kubernetes you need to configure. For example, ingresses, domains, these are inbuilt with Cloud Foundry, and you can just get started quicker. We also have a talk, I don't know if it's tomorrow, or you can find it on YouTube, from our product owner Maurice there, and it's called To the Cloud Within 5 Minutes. And this is way easier within Cloud Foundry, I would say. So a bit more simple, or you want to get started easier, go to Cloud Foundry, and Kubernetes, it's a bit more complex, but also more configuration freedom. Hope that clears it for you. Okay. Again, you have any questions to me, also to the other colleagues? Anything? Otherwise, we are done here. Like I said, you can find us on the Sunset Social. We will be there. Let's see if Felix wants some drinks, he said. So we will stay there for some times. You've seen now a lot of SKE faces. Just come to us, talk to us. We're looking forward meeting you there. All right? Then thank you very much.